Quick little rundown of my circuit here, which I designed, but then forgot what I did. Well, not completely, but it took me a second, so I figured I'd save myself some time in the future explaining what I've done here. Now, obviously, we've got a dial here. It's analog and a push button, and that is going to be controlling a PWM signal. What's cool about this is that PWM signal is achieved with a capacitor and two diodes and a resistor, I believe, hooked up to a 74HC14. It exploits the Schmitt trigger functionality of a D-bounce. Or not a D-bounce, but exploits the Schmitt trigger to make a PWM signal. So how this works? Well, there's three inputs for the pot, P1, 2, and 3. Those go down here. Quick note, there's actually pin 1, and then there's the button, and then 2 and 3. It's kind of a weird pinout, but whatever. So that's the pot. We have a P-channel FET here, and I've actually added a 100K resistor to the source, so that way the gate is always pulled high. You don't have to worry about connecting another high signal there. But then the source goes to around the board to V in, because that's going to be our power input, and that V in, I can connect power there, or I can connect it to P in now, because they're connected to in the same way. By doing it this way, the V in at least has a fuse. There's F1 on this side, so it fuses the whole circuit by connecting to V in here, instead of jumping it somewhere else. Now you'll see the third pin on our 4-pin FPC is right here. This is just the center. I added this when I designed this. This is the button. Kind of a nice little trick. Under the button you have a little solder pad for the button. And then of course we have a switch. So whatever reason, it's pretty arbitrary, I used switch 3. This is the common for switch 3, and then there's A and B. And so A goes to the PWM, and then, I've hooked up B to the gate, but actually the gate should go to the common. So the common either goes to PWM or it goes to floating. I should probably tie that floating pin to something, although is it an output? It's an output from the 74HC4053, and yeah, that'll do high Z outputs, so I don't want to keep that floating. Okay, I was trying to save a wire, but basically the other one will go to positive voltage, basically anywhere, to bring the gate high, which means I don't need that resistor. Whatever. And then, so then the power input can go here on this broken trace, or V in on the other side of the board. Ground is right here. I remember adding that. And then the output is this huge tab here, which of course this was designed to accommodate a SOT23 FET or a DPAC FET, which is a TO-263. It's a pretty nifty little design here. And yeah, that's the rundown.